not a loud one.
All right, here we go. One of the emphasis on the final is going to be substituting and solving systems of equations with substitution, solving them by hand with substitution. It's going to test your algebra skills, and in this problem, it's going to test your ability to solve a quadratic equation. All right, so the problem I'm taking is from page 575. It is number 17. And here's our system. All right, let's talk about the system before we get started. First of all, what can we expect for a solution? That top equation should look familiar. That top equation is actually a circle with radius 3. So if I were to sketch, just sketch what the graph of these two things might look like. It's a circle with a radius 3. It's centered at the origin. There it is. Let's just say that one. And then the second equation is just a line. I don't know what the line looks like. It's going to be negative with a positive slope. So it kind of looks like that. Question is, how many times do they intersect? Twice. Twice. We have two solutions. So at least we have some expectation about what our solution is going to look like. All right. Let's just mount it here. So we can start making one of the variables isolated by itself. Definitely easiest to get that variable isolated because it's already by itself. Just do that by adding 3y to both sides. So x is equal to 1 plus 3y. Now that I have that solved for x, I can substitute that expression back into the first equation for x. So if I take this equation and replace x with this expression, I'm going to square that expression. This is x squared plus y squared. Now we're just going to solve for y. It's going to be a quadratic equation. If it's a quadratic equation, you always want it to be equal to 0. You want all of the terms, let's say in this case we'll have all of the terms on the left side of the equation. So to start, first we're going to have to FOIL this squared term here. So let's do that first. So I'm going to write it out. Now we got to FOIL it. First term is 1 times 1. Second term is 3y times 1. And then 3y times 1, combine those to be 6y. The last two terms, 3y times 3y, 9y squared. And it's FOILed. Alright, we got to combine the y squareds, and I like writing the y squared term first. 9y plus 1y squared makes 10y squared, 6y, and 1 equals 9. Last step, let's make it equal to 0. Subtract 9. There we go. Okay. So we got all the terms on one side. It's equal to 0. Let's see here. It looks kind of ugly right now. We can factor out 2. All the terms out 2 it. Let's see if that helps us. Alright, at this point, you have a couple options. You can try and factor this by hand. This one's a little ugly. I'm going to start to try and think about that in my head and see if I can factor this out. What it would look like, it would have to look like a 5y and a y. And I might have to guess and check the things that add to be 4. 2 and 2, 10 and 2, no. 4 and 1, no. I don't think that's going to work. Alright? That's okay though, we always have the quadratic formula. I'm going to cruise through that real quick. This is A, this is B, and this is C. Alright, so quadratic formula, I'm not going to write it out, I'm just going to do it. Negative B, negative 3, plus or minus 3 squared minus 4ac, so 4 times 5 times negative 4. All over 2 times a, 2 times 5. Alright, let's start simplifying. 9. And then negative 4 times 5 is 20. Times negative 4 is a positive 80. And on the bottom we have 10. Alright, so negative 3 plus or minus square root of 89 over 10. Yeah. Square root of 89. 89, I believe, is a prime number. We cannot simplify that radical. Alright, this is what we've got here. Let's see here real quickly, just to get some decimal approximations of what that answer is. Negative 3 plus the square root of 89 divided by 10. So our first solution is x equals 0.64. Or our second solution is negative 3 minus square root of 89 divided by 10 is negative 1.24. Now, all right, remember, this is a system of equations. We have 2 points where they intersect. 2 points. I need an x and a y for each point. We found the x's for each point. We just got to go through and find the y's of each point. What did I do? No, my bad. We found the y's. Our equation was in terms of y. My bad. This should be y. So actually, what we did is we found the y's. Nice. All right, whatever. We just got to go back and find the x's. I like this equation right here. It's nice and simple. So, x is going to be equal to 1 plus 3 times 0.64. And x is going to be equal to 1 plus 3 times negative 1.24. I'm going to calculate those real quick. 1 plus 3 times 0.64. So the x term here is 2.92. The x term over there negative 2.72. Let me clean this up a little bit. Solution. Solution. Time lesson. Might we do this? Maybe I won't.